All right, let's go ahead and review some formulas that we've been working on, and finding the length of a line segment or the side of a polygon or the length of a median or altitude, finding length in general. Jamie, what equation do we use?
The distance. It's the square root of the change in x squared plus the change in y squared.
Good. From time to time, we have reason to need the midpoint of a line, and if I wanted to find the midpoint of a segment, Jamie, what equation would we use?
The x, or well, m equals x1 plus x2 over 2, and y1 plus y2 over 2, in parentheses.
There we go. We've talked a lot lately about finding the slant of a line, or we call this class the slope of a line. And what's my equation to find slope? Jamie?
Y2 minus y1 over x2 minus x1.
Good. And part of the slope or the slant of a line also allows you to find the angle that the line makes with the positive x-axis. We call this angle the class angle of inclination. How do we find angle of inclination? Jamie?
The arctangent of slope.
Good. And what do we use to represent angle of inclination?
Oh, alpha.
Alpha. So we'd say that alpha is equal to the arctangent of the slope. And we used these equations in our homework last night. One more thing before we get into this. Talking about slope, of course we said there's 4 kinds of slope, right? A line that seems to go downward, class, we would say has negative slope, but it's straight up and down, vertical. Undefined. Horizontal. 0. This seems to be going upward. Positive slope. And of course angles of inclination are changed with those as well, as we talked about. But if 2 lines never intersect, everywhere the same distance apart, for that to happen, for the lines to be class parallel, from our last lesson, what would have to be true, Jamie?
Same slope. Same
slope. So parallel lines, we remember, have the same slope. And for lines to form right angles with each other, we would call these lines class perpendicular. To have perpendicular lines, what must be true? Jamie?
Negative reciprocal slope.
Negative reciprocal slopes. Out of curiosity, it's been a little while. Did you remember that from Algebra 1 and Algebra 2? Or was it kind of a, okay, let me write that in the notes. I've never heard that before. Okay, that's all right. So the homework was attempting to use all of this information kind of in one problem. And we had the point R was 3, 7, and N was 1, negative 3. Rn, really weird, well, at least odd, very odd endpoints there. And you were supposed to find the length of Rn. And what did you get for that length, Quentin?
2 times square root of 26.
Good. Initially square root of 104. Of course, that factors into 4 times 26 to get 2 times the square root of 26 units. We then needed to find the midpoint of Rn. And what was that midpoint, Jamie?
2,
2, 2. We wanted to find the slope of Rn. And what did you get for that slope, Quentin? 5. And then the angle of inclination of Rn. What did you get for that, Jamie? Assuming the slope was correct. Did you get 5? Okay, what was your angle of inclination?
78.7 degrees.
All right. Did you get all 4 of these answers correct?
I did not get the distance.
Did not get the distance. Make sure that's a raised dot pretty clearly as opposed to a decimal.
All
right, so the change in x is 10, so that's 100. Change in y is 2, so that's 4, and that's where the 104 comes from.
Okay.
What did you have for your distance?
I had square root of 20.
Square root of 28?
No, just the square root of 20.
Square root of 20. You saw 4 instead of 10.
Okay.
And it got 16, and then here you got the 2 squared is 4, but yeah, here the distance between a 7 and a negative 3 is 10. All right, from there then, I asked you, well, let's suppose there's another line called CT. What is the slope of CT if CT is parallel to Rn? Jamie, what did you get for CT's slope?
I did not do that part.
All right, well, whenever I see parallel, I need to think 2 words.
Same slope.
Same slope. So if CT is parallel to Rn, it's going to have the same slope as Rn, so what's CT's slope?
5.
5.
I did have it, I just wrote it differently.
Okay, and then what are the slope of RA if RA is perpendicular to Rn? And again, whenever we see perpendicular, we need to think three words, Jamie.
Negative reciprocal slope.
Okay, so if RN slope is 5 and RA is perpendicular, what is RA's slope?
Negative 1/5.
Negative 1/5. Is that what we had for those two answers? All right, any questions on this part of the homework before we turn in our books to page 210? All right, let's go and turn to page 210 then. And you did number 3D for homework. And go and read the instructions that you were given for number 3. You don't have to read the points in D, just read those instructions if you would. Jamie.
Find the slope of the altitude on each side of triangle ABC.
Find the slope of the altitude on each side of the triangle. All right, so altitude from yesterday, good review. Altitude class means perpendicular, right? So in a triangle, there are 3 altitudes, 3 perpendiculars. We have an altitude here. We have an altitude here. That wouldn't be perpendicular. And then we've got an altitude here. By the way, do you remember the name of the point where the 3 altitudes intersect? Orthocenter. Good, the orthocenter. And but we're not finding that right now. We just want to find the slopes of these altitudes. Well, since altitude means perpendicular to the opposite side in each case, then what we need to do first is find the slope of the opposite side, and each altitude slope will be the negative reciprocal. So for triangle ABC, we were given on the letter D, A is negative 2, negative 3, B is 3, 6, C is negative 5, 5. We need to find, first of all, the slope of AB. And what did you get for the slope of AB? Jamie?
9/5.
9/5. Okay, so then let's go blue here for this altitude. What would be the slope of the altitude on AB, Jamie?
Negative 5/9.
Negative 5/9. What did we get for the slope of BC, Quentin?
1/8.
1/8. All right, so let's go green here. I'm not in on the Green New Deal or anything. What did we get for the slope of the altitude on BC, Quentin?
-8.
-8. What do we get for the slope of AC, Jamie?
Negative 8/3.
Negative 8/3. Okay, so we'll go purple. Whatever. I can't trace on top of a thing to save my life. Maybe that looks more perpendicular. I don't know. So what do we get for the slope of the altitude on AC, Jamie?
3/8.
3/8. We're going to go on all 3 slopes of altitudes. Any questions on 3D? All right, let's go to 6B now. Go ahead and read 6, what we're going to be doing here. Quentin?
Show that the median to the long side of triangle ABC is also an altitude.
Now remember yesterday, this is what we were working on. This is what we were working on at the end of the hour. And we said that there is a particular type of triangle in which the altitude to a specific side will also be the median and will be a perpendicular bisector. What type of triangle is this? Isosceles more generally, right? Equilateral, that's going to be true. But in an isosceles triangle, you're going to have 2 equal sides and a non-equal side. And whatever the median is will also be perpendicular, will be the altitude. Now, in this case, they're going to say that we've got 2 short sides and a long side. And so the 2 shorter sides are going to be the legs. That's not always the case, right? Very often in geometry, when I drew them, it doesn't really matter how you draw, we don't trust our eyes, I'd make the long sides the legs, the short side the base, right? But it could be a long base and 2 short legs. And that's what we've got here is 2 short legs. Really should have recorded this next year. Picking on Kendall and she's not even here. Poor Kendall. All right, who knows? Maybe I'll be out sick when this lesson is needed to be done, and next year Kendall will watch this in my absence, and my video self will get Kendall. Or maybe it'll just be a wasted joke. All right, number 6B. Let's take a look at the points here, and go ahead and draw a sketch of a triangle. Again, it doesn't have to be perfect. Probably better if you drew an equilateral, actually. That way it doesn't matter which 2 sides are equal and which 2 sides aren't. I'm going to draw it kind of equilaterally. And we've got A is 212, B is -6, -3, and C is 11, -3. All right, It says, show that the median to the longest side is an altitude. Well, what am I going to have to do first here, Jamie?
Get the slopes.
Show that the median to the longest side is an altitude.
Figure out the slopes of each altitude.
Well, but I don't. Quentin?
Figure out the.
Well, let's think this through. Okay, I'm going to show something. The end goal is show something's an altitude, right? So what's an altitude?
At the median.
A median. Okay, but which median? All three medians? No, just one. Which one?
To the longest side.
The one to the longest side. So altitude is the end goal. But before I can get altitude, I've got to figure out median. And before I can figure out median, I got to figure out which side is the longest. So what should I do first? Find the lengths of all three sides. All right, what do you get for the length of AC, first of all, Jamie?
3 times the square root of 34.
Good. Initially, the square root of 306. Now, if I'm writing this as an answer, I'll reduce it down. I really don't even need to do this step because all I really care about is which one's the biggest. So I could leave square root of 306, but a good job reducing it. What about for BC? What did you get for that length, Quentin?
Square root of 289.
And this one actually comes out evenly to 17 units, so that's not a bad one to get it all. By the way, notice these points would be horizontal to each other, right? Over 11 down 3, back 6 down 3. They're collinear or along a horizontal line. You could count those on a graph. And then what about AB? What's the length of a Jamie?
17.
Also, square root of 289 or 17 units. So which two sides are the legs here, class?
BC and AB.
BC and AB. Apparently this then is my base right here. And so we want to have, and again, slightly larger, not much. This is close to equilateral, right? We square root of 306, square root of 289. I mean, the square root of 306 is 17.49. I mean, 17 and a half, only half a unit longer. So very close to equilateral. But we want to find the median, which means we need the midpoint. So let's go and find now this midpoint of AC. And unfortunately, it's going to come out to fractional values, isn't it? Whoa, what do we get? Yeah, 13 halves, 9 halves is this midpoint. All right, and we want to show that the median, well, the median is going to go to this midpoint from point B. So since it goes from B to this midpoint, it might behoove me to rewrite these points as fractions. -6, for instance, class, could be written -12 halves, and the -3, -6 halves, might make it a little bit easier here to calculate some things with this median. All right, so it said show that the median to the longest side, okay, that's this line here to this side, here's midpoint. is also an altitude. Now, we know from geometry it ought to be, right? Because we have two equal sides, isosceles triangle. We know it ought to be. We prove it ought to be. Or it will be, rather. We just want to show the math comes along with that. How do I show something's an altitude? Perpendicular. How do I show perpendicular?
Negative reciprocal.
So I need to find two slopes. First, let's find the slope of AC. And then let's find the slope of the median, which is from B to the midpoint of AC. At your seats, find AC's slope. And what do we get?
Negative 15 over 9.
Okay, we could reduce that.
Negative 5 over 3.
And negative 5 to 3. Is that what you had as well? All right, now let's find the slope of the median. What is the change in y, class? 15 halves. What is the change in x?
25 halves.
25 halves. And if I have a complex fraction, of course we know I want to multiply by the reciprocal, 2 25ths. What do I end up with here for my slope? 3/5. Are these negative reciprocals?
Yes.
Then is this an altitude? It must be. It must be perpendicular. We could also, and I showed this last time, we could find that each half is, or each side is exactly half. They're equal segments there. We're not going to take the time to do that now. Questions? All right, let's go down to number 7. Go ahead and read all of 7, including parts A and B. Jamie.
Given A 5, 6, B 4, negative 2, C 3, negative 1, D x 7. Find x if AB is parallel to CD, or B AB is perpendicular to CD.
All right, so they give us two lines. They tell us in part A that they're going to be parallel, and they tell us x7 is one of the points, meaning I know the ordinate is 7, but what's the x value? Here's the idea. I've got a line, AB. I've got another point, C. From C, I can draw a parallel. At some point, D is going to have an ordinate of 7. But what would the x value have to be for point D for this line to be parallel? Conversely, I could also draw a perpendicular. And imagine if I extended it far enough, or extended it far enough this way, for instance, rather, at some point, D could have the same ordinate of 7, right? But what's the x value going to be now? Does that make sense? I know point A, I know point B. What is A?
5, 6.
5, 6, and B?
4, negative 2.
4, negative 2, and C?
3, negative 1.
3, negative 1. All right, so if AB is parallel to CD, well, anytime you see parallel, you got to think same slope. Well, I can only find the slope of one of my lines. Which of my two lines, AB or CD, can I actually find the slope of?
AB.
Why can't I find the slope of CD? Because I don't know the x value, right? But I know that the slope of AB is, find it, 8. So therefore, what must the slope of CD be? It must be a slope of 8. Now here's the deal. I know that to find slope, I would use the formula m equals
Y.
Minus 5.
Y is minus 5.
if I wanted to find slope, that's what I would do, correct? Well, I don't need to find the slope. I know the slope. It's 8. Or we could make it a fraction and call this 8 over 1. Furthermore, I know one of my points is 3, negative 1. 3 is an x value. Negative 1 is a y value. The other point, I only know that the y is 7. I don't know the x. And you see that we could solve for x? At your seats, do so. At your seats, solve for x. You already did it in your head? Show off. And what is x then, Quentin?
4.
It is 4.
Okay, yes, I got it.
Got it? All right. I'm guessing Quentin did what I did, and I was like, well, that's going to be an 8. And that's an 8. So this is a 1. This has got to be 1. What would give me a 1? 4 minus 3 would give me a 1. So I'm guessing that's what you did? Yeah. Good observation. Good job. I like the way your brain works. All right. Or you could cross multiply and solve it that way. And that works just as well. Questions on that? All right. So now, what if AB is perpendicular to CD? So now we're going with this line. Well, now I need to find x this way. Well, if AB is still a slope of 8, correct? But if CD is perpendicular, what is CD's slope, class? Negative 1/8. We could do the same thing. M equals y2 minus y1 over x2 minus x1, but this time the slope is negative 1 over 8, or 1 over negative 8, right? Here might be a little more algebra involved. Not as easy to do in our head this time. What x value would I have to get a perpendicular? I can't do it in my head. I'm going to put the negative down here with the 8. I like that better. And did you get?
Yes.
Negative 61. Aren't you glad we don't do graph it?
Weird.
Up till then we were fine. Like we could have actually set up, a Cartesian plane here and actually plotted, 4, negative 2, and 5, 6. Okay, so here's my AB. And C is 3, negative 1, and D is 4, 7, and we could see parallel, right? Well, you get perpendicular. You still needed that 7. There's perpendicular. Way back here, same ordinate of 7 would be negative 61. 7 is where my other D would have to be to get a perpendicular. All right, so you can kind of see that with the graph. It's just, man, aren't you glad we didn't have to? All right, questions on this? All right, let's drop down to number 10 now. Go ahead and read number 10 for us, if you would. Jamie.
A circle with a center at 0, 0 intersects or touches a given line. If tangents to the circle are drawn at the points of intersection, find the slope of the tangent.
All right. Read it again for me, Quentin.
The circle with a center at 0, 0 intersects or touches a given line. If tangents to the circle are drawn at the points of intersection, find the slopes of the tangents. Okay,
so we've got a circle, x squared plus y squared, which has its center at 0, 0. We talked about this way back when we first talked about ACT prep, right? I said if you got x squared plus y squared, that's going to be the form of a circle. We've also got a line, 7x minus y equals 25. All right, so we have a circle, center at 0, 0. We have a line. Circle and line should intersect how many times? Once or twice, presumably twice. Right? If it's only once, it would already be tangent. So let's assume we have circle here, and we have line. And line intersects at 2 points. Well, at each point, I could draw a tangent to the circle, correct? The question is, what is the slope of this tangent? What is the slope of this tangent? Well, in order to know that, first of all, we got to figure out what are these 2 points of intersection. We know the center of the circle, by the way, is 0, 0. But what are these 2 points? Well, how would I find these 2 points of intersection? Solve the system, right? Going back to chapter 10, solve the system. Set your seats, take a moment, solve this system of equations, and find the points of intersection between the line and the circle. like they took a sun and turned it into a blizzard. I'm gonna turn the air on. Check your algebra here. How did we do on the initial algebra steps? Good to go?
I have got double.
Oh, I forgot to multiply. No, it's here at 175x, and that was going to make it really hard to solve. Okay, go and update your work. Go and get it correct. Now, that's two x values. That's not the 0.34. That's an x value of 3 and an x value of 4. We need to go back and find the y values. Well, if you plug a 3 in here, what do we get for y class? Negative 4. If you plug a 4 in here, what do we get for x class? 3. So these are my 2 points of tangency. These are the 2 points of intersection, but that also means they're going to be the 2 points where the tangents are drawn through. The slope of a tangent? Well, what does tangent mean? Besides the fact that it touches a circle at only one point. Going back to geometry class, we said when you see tangent, what was the claim response? Perpendicular. Tangents are perpendicular to what?
To any.
A tangent is always going to be perpendicular to what?
Diameter?
Diameter or radius, correct? Radius or diameter drawn to the point of tangency. So I've got my center at 0, 0. If I draw this radius will have a certain slope. The tangent will be perpendicular or have negative reciprocal slope. Similarly here, this tangent, this radius here will have a certain slope. The tangent will have negative reciprocal slope. Does that make sense? So let's start with this radius right here. What would be the slope of the radius from 0, 0 to 3, negative 4? Negative 4/3. All right, so what's going to be the slope of this tangent then, class? 3/4. Negative reciprocal. So one of my tangents, if tangents are drawn at the points of intersection between this line and this circle, one of the tangents will have a slope of 3/4. All right, what's the slope of this radius from 0, 0 to 4, 3?
Negative 3/4.
From 0, 0 to 4, 3.
3/4.
3/4. All right, so if that's the slope of this radius, what would be the slope of this tangent? And there's the answers that they were looking for. These are the two slopes of the two tangents. Now, questions, comments on the slopes of the tangents? They are negative reciprocals, which means apparently my tangents are perpendicular. Furthermore, look at the radii. The radii must also be perpendicular. So apparently what I've got going here is in my circle, I have perpendicular to radii, and therefore I have perpendicular tangents, which means that where these two tangents meet and these radii are drawn, I form a square. Must be a square because we have equal radii. Okay, so all kinds of cool stuff we can see without actually graphing it on the Cartesian plane. Actually, I guess if we did graph it on the Cartesian plane, right? Remember, we're going to get to this in a little bit, but from the ACT, I said if you see x squared plus y squared, it means circle at the origin. And this is the radius squared. So what's the radius of my circle? 5. So go out 5, up 5, around 5 in all directions. I've got a circle that's going to look something like this, going out to the 5s and the negative 5s. Now I've got points of intersection at 4, 3, and 3, negative 4. So apparently the line 7x minus y equals 25 is going to look something like this. If I drew radii to these points, notice the radii are perpendicular. So then if I drew tangents at these points, there's a tangent and there's a tangent. And there's a little square that would be formed if it were drawn perfectly. All right, questions on that? All right. Questions at all on slopes, on angles of inclination, all stuff like that there? Any questions at all? All right. I want to kind of preview what we're going to get to in our next lesson. Look across the page, page 211, and you see a term that you should recognize from geometry class. And of course, that term is locus. You remember talking about the locus? Remember that a locus, you might jot this in your notes, a locus refers to the set of all points, and only those points that satisfy a given condition or conditions. The set of all points, and only those points that satisfy a certain given condition or conditions. You'll recall that a locus is inclusive and exclusive. A locus in geometry class had to include every possibility and exclude anything that wasn't a possibility. We had some memorized loci, right? All the points that are equidistant from the sides of an angle, remember, described the angle bisector. So if you have some angle, every point equidistant from these two sides of the angle would be in that angle bisector. If I had all the points equidistant from two given points.
Midpoint?
The midpoint of the line drawn between those two points.
There would be the midpoint, but there's other points that are equidistant as well.
It would be the line perpendicular to the line drawn between.
Right, it would be the perpendicular bisector of the segment that could be drawn between the points. If I had just a random point and I had some given distance, all the points this distance from that point.
That distance would be a radius.
A circle with this point as center and that given distance is the radius. You remember that now coming back to? Okay. Well, in geometry, we had to just say it is a circle with the point as center and the distance as radius. It's the perpendicular bisector. It's the angle bisector. Well, this is a line. I could get the equation of that line. I could get the equation of this line. I could get the equation of this circle. So we're going to take loci a step further. We're not just going to say, well, it's a line. We're going to say it's this equation specifically. We also did something where we said, okay, well, how many points, or what are all the points that are this distance from that line and this distance from that point? Well, what we would do is we would show this distance from the given line, and we say this distance from this point. And we might say, okay, well, there's 2 points that satisfy. Remember that? Now, in some cases, we might say, well, but what if it weren't this line? What if it were just a line? Well, that line could be anywhere, right? We get 4 points, we get 3 points, we get 1 point. You remember? No. Well, here, if they gave us a specific line's equation and a distance from it, and a specific point and a distance from it, I could figure the equations of these lines, the equation of this circle, and therefore not just the fact that there are 2 points, but exactly which 2 points. We can take geometry, which looked at basic loci, to a whole nother level if we combine it with algebra. And that's where analytic geometry comes in. So that's what's kind of coming. I want to review some terminology for you, though, as we see different loci described to us. You see the yellow box there on page 211. Most of these you should be really good with, right? If you see the word is, we know it means equals. If you see greater than, more than, or increased by, we would add. If you see less than, we... Now remember, the word than means flip that order around, remember? Abscissa always refers to x, and ordinate refers to... By the way, what if it said coordinates? X and y, right? Anytime it talks about distance, remember that's going to imply shortest distance. A couple other distance reminders. If you have 2 points, how would I define the distance? The straight line, and we would use the distance formula. If I had a point and a line, how would I define the distance?
The perpendicular.
The length of the perpendicular, right? From this point to that point. How if I had 2 parallel lines would I define the distance?
Line parallel equidistant from both.
Any perpendicular between them. So find any point, find a point that would be perpendicular across from it, find the length of any perpendicular between the points. So some things there. Look at the example problem, if you would. Go and read, actually, the example problem for me, Jamie.
Find the locus of points on the Cartesian plane such that the ordinate less than the abscissa is product of the coordinates.
Sounds really fancy, don't it?
Mm-hmm.
Find the locus of points. That means we're going to write an equation. Okay, in geometry, we didn't write an equation. We described a picture. It's pre-cal now. We write equations. On the Cartesian plane, okay, that means we're going to use x's and y's, such that the ordinate less than the abscissa. How would I write ordinate less than the abscissa? X minus y, right? Ordinate, that's y, less than, okay, something minus y, the abscissa, okay, that's x, so x minus y. It says is, okay, that means the product of, that means we're going to multiply the coordinates. Well, what are we going to multiply? X and y. That equation is that locus. Does that make sense? Some problems are going to be that easy, where you just literally are translating. Let's take a look at some easy ones like that. Page 213. Letter A. We're finding the locus of points if we're given what in letter A, Quentin?
Ordinate is 1 greater than twice the abscissa.
All right, all the points, the locus of all points for which the ordinate is 1 greater than twice the abscissa. Well, those points would be a straight line. But what straight line? Jamie, what do you have?
I have y plus 1, right? Oh, no, y equals 1 plus 2x.
Good. I would probably say 2x plus 1 because of the then I'd flip it, but it's not wrong. Right? There's a linear equation. Y-intercept of 1, slope of 2, right? Slope-intercept form from your algebra days. But this equation represents all the points and only those points that satisfy that condition in letter A. Does that make sense? All right, letter B. Go and read that one for us if you would, Jamie.
Abscissa is 1/2 the square of the ordinate.
All right, at your seats, write the equation that describes all the points and only those points for which the abscissa is 1/2 the square of the ordinate. And Quentin, what you got? X equals y squared over 2. Or you could say x equals 1/2 y squared. I like the y squared over 2 better. But hey, you know that's going to be what shape? Parabola. 1 squared, 1 isn't. So all the points that satisfy are going to lie within this specific parabola that, by the way, is symmetric to the x-axis. Because you, or the, plug in negative y. Yeah, the x-axis. So you plug in a negative in for the y, right? So above and below the x-axis, you're going to get that parabola. And every point in that particular parabola would satisfy that condition. Letter C at your seats. Or letter C at your seats. And what did you get for this one, Jamie?
X squared plus y squared equals 25.
Yeah, that's that circle we had just a minute ago with a radius of 5 centered at the origin. X squared plus y squared equals 25. Letter D at your seats. And what'd you get for this one, Quentin?
X plus y equals y squared minus x squared.
Okay, you went ahead and flipped it around, but that's not wrong. X plus y equals y squared minus x squared. That's correct. I would have started with the y squared minus x squared equals x plus y, and I would have gone that route. But here we have a hyperbola, because notice they're both squared, but there's a subtraction involved. So this particular hyperbola would describe all the points for which that condition is true. Here's a fun one, letter E. Distance from the x-axis is 2. Now think about it. What is the x-axis? It is a, what shape? What shape is the x-axis? A line. A given distance from a given line. What am I going to get? Think back to geometry. Given distance from a given line, what am I going to have? The locus of points a given distance from a given line. I'm going to get 2 lines. Each parallel to the given line, give a given distance away on either side. Let's suppose I go a distance of 2 from the x-axis. Parallel to the x-axis, 2 units away. Parallel to the x-axis, 2 units away on the other side, right? This is how we would have drawn the locus in geometry class. What is the equation of this line? Well, what's its slope? Both of them have a slope of 0, right? But since they all have an ordinate of 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, we could just say this line is y equals 2. And this line could be written
Y equals 100%.
So how could I write a single equation that describes this locus?
2 is,
Well, y equals positive negative 2. And this equation fully describes the locus of points. Okay, now your turn, letter F. Distance from y-axis is 7. The distance from the y-axis is 7.
Would be x equals positive negative 7?
Good. Y-axis is here, 7 units away, and 7 units away on the other side. Well, what's true of every point here? They all have an x value of 7. All of these have an x value of negative 7. X equals positive negative 7. Letter G. The distance from the x-axis equals the distance to the y-axis. So equal distance, equidistant from the axes. Well, question, when you draw these axes, you have intersecting lines, don't you? Do you remember if we had intersecting lines, how we could describe all points equidistant from intersecting lines? Two lines that bisect the pairs of vertical angles. Well, if I were to bisect the pairs of vertical angles here, I would get a 45-degree angle here and a 135-degree angle here technically. But think about the points. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4. How can we write that as an equation? Negative 5, negative 5. Negative 6, negative 6. Negative 7, negative 7.
X equals y.
X equals y. Now think about this line. 0, 0. Negative 1, 1. Negative 2, 2. Negative 3, 3. Negative 4, 4. 1, negative 1. 2, negative 2. 3, negative 3. Y equals negative x. Or we could say, since y equals x and negative x, y equals positive negative x. So we're taking geometry ideas and putting equations to them. Okay? Let's go and stop there for today. I want to give you a homework assignment. I want to give you a triangle. Triangle GCS. And G is the point 2, negative 3. C is the point 7, 1. And let me erase my intersecting lines example here. Excuse me. And S is the point, where'd I go, 4, 5. All right, so we're given triangle GCS with G, 2, negative 3, C, 7, 1, and S, 4, 5. I only want you to find 3 things. I want you to find the slope of the median to the longest side. I want you to find the slope of the altitude to the shortest side, and I want you to find the measure of angle G. I want you to find the slope of the median to the longest side, the slope of the altitude to the shortest side, and the measure of angle G. We'll take a look at all of that in our next lesson. Have a wonderful rest of your day, and when the bell rings, you will be dismissed.